Hello, my dear students. In the previous session, we have discussed about the electric potential and potential difference, and also we have learned about the electric current. In the today's session, we are going to understand what do we mean by electrical circuits, and also we are going to study the Ohm's law. Yes, let's get started. First, we shall understand what do we mean by electrical circuits. Electric circuit, it is a continuous closed path where the electric current flows, and it consists of a source of electric current and other electrical components like voltmeter, ammeter, rheostat, resistors, etc. So, electric circuit, it is a continuous conducting path of electric current consisting of a source of electric current and other electrical components. Simple electrical circuit can be represented as, and always the current flows from higher potential to lower potential. We'll show the direction of current as, and the voltmeter is always connected in parallel in the electrical circuits. This is a representation of a simple electrical circuit. This is a source of electric current which is used to maintain the potential difference. That is, it is a cell. You can also connect many cells together, which is called as battery. This is voltmeter. We know that always it is connected in parallel in the circuit, and ammeter, it is always connected in series. And the direction of current is shown in such a way that it will always flows from higher potential to lower potential. Means it is opposite to the direction of flow of electrons. The direction of flow of electrons is in this direction. We are showing conventionally the electric current in this direction. You have to remember this. And also switch is connected in the circuit. It is used to switch on and switch off the electric current flowing through it. If I show the plug key or switch in this way, then the current is flowing in the circuit, which means it is switched on. If I show the switch like this, then it is switched off, where the current is not flowing in the circuit. This is about the simple electrical circuit here. Let us understand some of the symbols used for different electrical components. Symbols used for different electrical components. Electric cell is represented as, where this is a positive terminal and this is negative terminal. And a battery or combination of the electric cells is represented as, it is the combination of different cells. And plug key, as we had seen, it is represented as like this. If it is closed, means switch on, and the plug key is open, it is shown as, means the circuit is not still complete and the current is not flowing. It is in the switched off condition. Next, a wire joint. It is the wire joint where the wires are connected like this. If the wires are crossing without joining, then it is shown as like this. These are the two wires where these two wires are not joining. If these two wires are connecting, then it is shown as like this. But if these two wires are not connected, then it is shown in this way. Then as we know, electric bulb is shown as like this. Then a resistor is shown by the symbol. You will come to know about the resistor when we study the Ohm's law. Right now you remember this symbol. It is shown as in this way. This is the symbol for resistor, where the resistance of this resistor is fixed. Variable resistance or rheostat. It is shown as like this. It is shown as this resistor is having variable resistance. So it is called as rheostat. Next, as we know, ammeter is shown by the symbol like this, and voltmeter is shown as like this. So you have to remember these symbols of electrical components. So it is an electric cell. When there is a combination of different number of cells, we call it as battery. Then plug key. It is also called as switch. If it is closed, it is shown as like this. If it is open, it is shown in this way. Then a wire joint where the wires are joined. They are connected. It is shown by this symbol. Then if the wires are not connected, they are simply crossing. It is shown like this. Then it is a representation of bulb. This is a resistor and this is a variable resistor. It is also called as rheostat. It is ammeter and this is voltmeter. This is how we will show different symbols for different electrical components. Now we are going to understand about the Ohm's law. This law is very important from the examination point of view. We will also get numericals based on this law. Before going to understand what is Ohm's law, let us understand one day-to-day example. Suppose these are two water tanks having same amount of water in both the tanks. Now these two tanks have outlets. The outlet of the first tank is here and the outlet of second tank is here. The only difference is it is in the height. Now let's see how the water passes through these outlets. Now you can see the jet of water in both the cases. In the first case, the stream of water or the jet of water, it is of less force when compared to this here. Here the water is falling at a longer distance from this tank, means it is falling with more speed. Here the water is falling with more speed when compared to this. It is falling with less speed. The force with which the water is falling in this tank, that is tank number 1, is less when compared to the force with which the water is flowing here in the tank 2. Why does this happen? It is due to the pressure difference. In this case, you can see here the height difference is less, because of which the pressure difference between these layers of water is also less in this case. Whereas here there is more height difference, means there is more pressure difference in this case, because of which the water will flow with more speed in this case. Because of which the speed of these water jet will vary because of the pressure difference. As you see here, the pressure difference will cause the different speed of jet of water or stream of water. In the same way, in an electrical circuit, the current which flows through it depends on the voltage or the potential difference. In that case, we are not talking about the height there. What we are concerned about is we are concerned about the potential difference. More the potential difference, more current will flow through the conductor. This is what Ohm's law gives the relation between the potential difference and current flowing through a conductor. So, this Ohm's law gives the relation between potential difference V and I. So, what does this Ohm's law states? It states that the potential difference V across a metallic wire in a conductor, it is directly proportional to the current flowing through the conductor, provided the temperature and other physical states of the conductor remains the same. So this law is given by, it is given by the scientist George Simon Ohm. What is the statement of this law? It states that the potential difference V across the ends of a metallic wire in an electrical circuit is directly proportional to, it is directly proportional to what? It is directly proportional to the current flowing through the conductor. Current flowing through it. And it's very important to mention its temperature remains the same provided its temperature remains the same. As I said, it is very important to mention that the temperature remains the same. According to this law, we get the potential difference V is directly proportional to the current flowing through the conductor, provided the temperature of the conductor remains the same. Now, if we remove the proportionality sign, we get a constant. You can also write it as V is equal to IR. This is called as Ohm's law. What is this R then? This R is a constant which is called as resistance. And this resistance is not depend on the voltage and current. In this equation you can see this is constant. It is independent of the voltage and current. But it depends on the nature of the material at a given temperature. So you have to mention resistance is constant for a given material, for a given metallic wire or any conducting material at a given temperature. This resistance, it is constant for a given metallic wire, which means this is depending on the nature of material and also it depends on temperature. But at a particular temperature, this is constant for a given metallic wire. You have to remember this. So this is the graphical representation of potential difference versus current, that is Ohm's law. It is graphical representation of Ohm's law. As V is directly proportional to I, we get a straight line passing through the origin. If the potential difference is completely zero, then no current will pass through the electrical circuit. As we increase the potential difference, the current will also increase. And one more thing you have to observe here is the slope. When you take the slope of this graph, we know that slope is given by height upon base. That is equal to V upon I. What does this ratio represent? It represents the resistance which is equal to R. We know that V is equal to IR and R is given by V upon I. This V upon I is nothing but the resistance. So if I take the slope of the graph of potential difference versus electric current, we get the slope which is equal to the resistance. Hence, the Ohm's law holds good only when the temperature remains constant. Otherwise, if you change the temperature, then the resistance will also changes. So, this is about the graphical representation of Ohm's law. Now, let's understand more about resistance. It is a property of conductor by which it opposes the flow of electric current in the circuit. Remember that different materials have different resistance. As I have already said, this resistance depends on the nature of the material. And what is the meaning of this resistance? It is the property by which it opposes the flow of current in the electrical circuit. And in case of conductors, these electrons are not completely free to move. Suppose this is a conductor. It consists of many atoms here. Many number of atoms are also there along with the free electrons. Now these electrons must move in between these atoms, and while doing so they will collide with these atoms, because of which there is some resistance to the flow of electrons in these conductors. That opposition to the flow of electrons is called as resistance. Different materials have different resistance. Some materials have very less resistance. Some materials have more resistance. More the resistance, less is the current. Less the resistance, more will be the current. We know that from the Ohm's law, R is equal to V upon I, which means R is inversely proportional to I. So if there is more resistance, then less will be the current. More the resistance, less will be the current. Less the resistance, more will be the current. There are different types of materials which have different conductivities. For conductor, you can say the resistance is very low. They allow easy flow of electrons into them. The resistance is low. And among the conductors, silver is the best conductor because it is having very low resistance. And there are some other good conductors like aluminium, copper, which are used in our electrical circuits because they are good conductors of electricity, which means they are having low resistance. Good conductors means they offer low resistance to the flow of electric current. And for insulators, the resistance is very high. The resistance is very high, such that they will not allow the flow of electric current into them. Even if it flow, it is very negligible. You can't even detect the electric current flowing through them. For examples, glass, plastics, they are good examples for insulators. They offer very high resistance for the flow of electric current. Even if you say electric current is passing through them, it is very negligible. It is equivalent to no. And we will also come across some class of compounds like semiconductors, which you will study in your higher classes. Their conductivity is in between the conductors and insulators. You have to remember here one more point, that resistance can never be equal to zero, which means every material offers some amount of resistance. Even it may be very low, but it has some amount of resistance. The values of resistance vary from very low to very high, but it can never be equal to zero. Resistance can never be zero. And this resistance is given the symbol R. Now, what is the SI unit of this resistance? The SI unit of the resistance is ohm. The SI unit of resistance is ohm. And it is represented by this symbol. Now, how do you define 1 ohm? When the potential difference across the conductor is 1 volt and the current flowing through this is 1 ampere, then we say that the resistance of that material is 1 ohm. So 1 ohm is equal to 1 volt upon 1 ampere. So we define 1 ohm as when the potential difference across the conductor is 1 volt and 1 ampere of current is flowing through it. and 1 ampere of current is flowing through it, then resistance of that conductor is said to be 1 ohm. And we have learnt that R is inversely proportional to I. More the resistance, less is the current. Less the resistance, more is the current. Then not all the time we require more amount of current. Sometimes we require less amount of current into the electrical circuit. Sometimes we require more amount of electric current in the electrical circuit. We know that this electrical current is depending on the resistance. So by changing the resistance, we can change the amount of electric current flowing through the electrical circuit. And by keeping the voltage same. So the device which is used to vary the resistance is called as rheostat. A device called rheostat is used to regulate the current, which means in order to alter the current, regulate the current. By changing the resistance, we can change the amount of current flowing through the electrical circuit. For this, we are using the device called as rheostat, which will regulate the current. We are going to see here on what factors does the resistance of the material depends on. Factors affecting the resistance. Resistance of a conductor depends mainly on the 4 factors. That is, length of the conductor, area of cross section of the conductor, area of cross section of the conductor, nature of the material, and it also depends on the temperature, where we are not going into more depth towards the dependency on temperature here. So right now let us understand how this resistance is depending on these factors. Suppose this is a metallic wire. It is a conductor having length L and it is having area of cross section, that is A. What do we mean by area of cross section? This area which you are seeing here. What do we mean by the area of cross section? This area is called as area of cross section. We know that the wires which are used in the electrical appliances, they are cylindrical in shape and they have area of cross section. Now let's see here how the length of the conductor affects the resistance. More the length of the conductor, more will be the resistance. So the resistance is directly proportional to length of the conductor. When the length of the conductor increases, the resistance also increases. So in the electrical appliances, always the appropriate length of the conducting wires is used. You might have seen the chargers. Even though it is very convenient to use the charger wire of more length, but it is having some appropriate length, because as the length increases, the charging capacity decreases, because it offers more resistance to the electric current, because of which it is having the appropriate length. Then area of cross section of the conductor. You see here, this is the area of cross section. As the area of cross section increases, the resistance will decreases. It will offer less resistance to the flow of electric current, as more amount of charges can flow, as it is having the more area of cross section. So more the area of cross section, less will be the resistance. Less the area of cross section, more will be the resistance. Because as a conductor has a large cross sectional area, it will allow large amount of charges to pass through it. So it offers less resistance when it is having more area of cross section, and vice versa. So the resistance is inversely proportional to area of cross section. Suppose if we have taken the wire of same length having different cross-sectional area. They are having same length. Now, the resistance offered by this wire is more when compared to the resistance offered by this wire, because it is having more area of cross section and it will offer less resistance and allows more current to pass through it. So, area of cross section is inversely related to resistance. It is also depending on the nature of the material. So, by combining these two relations, we get R is directly proportional to L and inversely proportional to A. If I remove the proportionality constant, I get R is equal to a constant into L upon A. So, the proportionality constant rho is called as resistivity and it is represented by the symbol rho. The SI unit of this resistivity is ohm meter. And this resistivity is the characteristic property of the material. And also this resistance and resistivity, they are dependent on temperature also. You have to keep in this mind. For conductors, the value of resistivity is in the range of 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter. So, for conductor, resistivity values ranges between 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter, which shows they offer very low resistance to the flow of electric current. For insulators, the resistivity values are in the range of 10 raised to 12 ohm meter to 10 raised to 17 ohm meter. Means insulators offers high resistance to the flow of electric current as they are having high resistivities. Higher the resistivity, lower is the flow of electric current. Lesser the resistivity, more is the flow of electric current. And how do we get the SI unit of this resistivity? We know that this resistance is given by this formula. We can take rho and write the equation as A into R divided by L. SI unit of rho is equal to SI unit of A divided by SI unit of L into SI unit of resistance. So we know that SI unit of area is meter square and SI unit of resistance is ohm and SI unit of length is meter. So these two will get cancelled and we will get ohm meter. So SI unit of rho, rho, it is ohm meter. You have to remember this unit. And these formulas are very important for solving the numericals. You have to remember these formulas and units as well. Let us solve some questions here. The first, a wire of length L and resistance R is stretched so that the length is doubled and the area of cross section is halved. How will it resistance change B. Resistivity change. So understand the question properly here. The initial length of the wire is L and its resistance is R. Now it is stretched so that the length is doubled, means it is 2 times that of the initial length, and the area of cross section is halved, means it becomes half of the initial value. Now we have to find out how will its resistance change and its resistivity change. Suppose this is a wire. It is having length L. Once it is stretched, what happens? Its area of cross section will be halved. Initially the area of cross section was A. Now it is stretched so that the area of cross section will be half of the initial value. Now we have to find out the resistance change here. Let R be the initial. Let R be the initial resistance of the wire. It is equal to rho L upon A. And once it is stretched, let's see here how the resistance changes. It will be R dash, so that rho, it is a constant, it will remains the same. The length is 2 times that of the initial value, so that it will be 2L. What about the area? Area has become half of the initial value. This 2 will go to upside, so that R dash will be, so this R dash will be 4 rho L upon A. You can see here this rho L upon A is the value of R. It is equal to the value of R. So I can write it as R dash is equal to 4R. Now how the resistance has changed? It has become 4 times that of the initial resistance. This is the resistance once the wire is stretched. Now they have also asked the resistivity change. Once I stretch any material, will the material change? No. Actually, only the parameters like length and area will change, but not the material, because of which resistivity remains the same. We know that resistivity of a particular material is same. It does not change by changing the length or area. So, if you change the length and area, then also the resistivity will not change because it is the property of a material. So, resistivity will not change as material is same. Yes. Let's see the next question. If the potential difference between the terminals of the electric motor is 220 volt and an electric current of 5 ampere is flowing through it, what will be the resistance of electric motor? See here, the potential difference between the terminals of the electric motor is 220 volt and an electric current of 5 ampere is flowing through it. Now we have to calculate the resistance of the electric motor. First let us write the given quantities first. The electric current I is equal to 5 ampere. Potential difference V is equal to 220 volt. What we have to find out? resistance of the electric motor. We know that from the Ohm's law, we have the formula R is equal to V upon I. So, substituting these values here, we get R is equal to 220 upon 5 ohm. I will get 5 fours are 5 fours are. So, 44 ohm. The resistance of electric motor is equal to 44 ohm. This is the answer.